Now, see here, find natural frequency of circuit containing inductance of 100 microhenry and a capacitor of 0.01 microfarad, to which wavelength its response will be maximum and for how long will the oscillations continue. In this case, see here, you are given L is equal to 100 microhenry, that is here 100 into 10 raised to power minus 6 Henry, that is 10 raised to power minus 4 Henry. And here we can write C is equal to 0.01 microfarad, that is 0.01 into 10 raised to power minus 6 farad, and that is your 1 into 10 raised to power minus 8 farad. We have to calculate frequency. So, nu is equal to 1 upon 2 pi under root of L C, and here we can write 1 upon 2 pi under root of 10 raised to power minus 4 into 10 raised to power minus 8, and that will be here 10 raised to power 6 after taking a square root upon 2 pi. When you solve it, you will be getting 159.2 kilohertz. This will be coming the frequency here. Now, after calculating frequency, we can calculate the wavelength. So, we know the relation between velocity is equal to frequency into wavelength. So, we can write wavelength lambda is equal to c upon nu. C is the speed of the electromagnetic waves, that is here 3 into 10 raised to power 8 upon, that is nu is here 159.2 into 10 raised to power 3, and this will be coming around 1.8 into 10 raised to power 3 meter. This is the wavelength. So, now after this, the last part is here, last part of the question, for how long will the oscillations continue? So, if we assume here there is no loss of energy, so this oscillation will continue for the long time, for the infinite time, if there is no loss of energy.